So will you give me 1 minute so I can on the light? Because
Yes,
light is off. Okay, so give me a minute. So I think it's bit better. So what do you mean by the motion?
motion is when it's the process of when an object moves its position or changes its position.
Okay, good. So what do we mean by the motion in a straight line?
Motion in straight line means when the object is moving in a straight pathway or straight direction.
Okay, that's called the motion in a straight line. So there are a few types of motion. Okay, the motion of a straight line is one of them. One is the circular motion. Okay, motion in uh, along the two-dimensional plane. This is the motion along the plane. So we will be confining ourselves to the motion along along a straight line, means motion in one dimension. Okay,
Okay.
one dimension. One dimension. So is the easiest problem to discuss motion in one dimension. Suppose we start from here. This is our starting point. With time is this scale is in kilometer. So it is marked 5, 10, 15, 20, and so on. It is similar as we studied in the coordinate geometry. You can relate it. The motion along the x-axis, the y coordinate is 0. So only one number is written over here. Right.
Yeah.
So this you may say this is origin. And with respect to origin, the distance is being marked. Right. A, B, C are the position of objects at any given amount of time. So at least to note the motion along a straight line, we need position, comma time. Okay, these two quantities are important because without time, the description is incomplete. Clear?
Yes, sir.
How it is incomplete? If you will say to your friend over phone that I am at home, I'm at home, right? Till
Okay.
7 a.m. Right? After 7 a.m., I'll be going to the school. So this is the time limiting point or the time. If he or she comes after this time, 7 a.m., he won't find you. Okay. So for the complete notation, you have to give the time as well.
Okay.
Did you say something?
No, sir, I didn't say anything.
Okay. So this is one of the notion. Time is attached with the position or our observation. Clear?
Yes, sir.
I think we will be doing in brief only. So after understanding the uniform motion, motion along a straight line. Now it's time to define the uniform motion and non-uniform motion. What does we mean? What you know about
Uniform motion is when the object is equal in equal distance in equal interval of time.
right? When object covers or travels equal distance in equal amount of time, right?
Yeah,
Similarly, will be for non-uniform motion, the opposite statement, right?
yeah.
So there is nothing. So whenever speed is involved, motion is involved, there is one intrinsic quantity called speed. Whenever there is motion, there will be a speed. Speed is what? Distance over
Time
and distance traveled
by time taken.
over time taken. Okay. Similarly, if we wanna see for any motion, take uniform or non-uniform. Suppose this is a speed and this is time. So for some distance, say 5 kilometers, we move with this speed. This is uniform speed. For again 5 kilometers, we move with some another speed. Okay, 5 kilometers. Somewhere we were going and stopping for coffee or something, and so on. Right. So
Yeah,
if we will calculate the average speed, how we will be doing?
the total distance traveled by total time taken.
Total time taken, right?
Yeah,
So it is seem like we are traveling by a train. So for some instant of time, train covers move with a good speed. With next interval of time, its speed is not that much good. So when we complete our journey, we come back and see how much time we taken, how much was the distance, and we calculate the average speed. Okay, so average speed is means that is the sum of all the velocities or sum of all the speed spread it over the time interval, right?
yeah,
So if you understand the concept average speed and this formula, can you do this example?
yeah.
Right.
So I got the answer.
You got the answer. How you solve it? How you solve it? Average speed is equal to
Oh, sorry, I was muted. Uh, you had 16 and 16 to get the total distance taken, travel, and uh, 4 plus 2 will give the total time taken. So then 32 divided by 6 will give you 5.33, like it continues, 5.333
meter per
meter
second,
per
right?
Yeah.
So We have the next question. Interesting.
So done.
Done. So what is the average velocity and what is the average speed?
Average speed I got is as 3 meter per second.
Total distance is 180. She covers 90 meter in 1 minute. She covers 180 meters in 1 minute.
It's 180 meter per 1
One
minute. And you have to convert into meter per second. So it'll be uh
second.
60 seconds, yeah.
So it will be 60 over this. So in 3 times, right?
Yeah.
What about the velocity?
Average velocity is displacement over time taken.
Mhm.
So it will be 0 by 60.
Okay, so you want to say that this is 0, right?
Yeah.
Okay, right. Good. Now we already know, and some point of time we have already discussed what is the rate change of velocity.
Rate change of velocity is when the object changes its speed and when it's in motion.
Yeah. Rate change of velocity means directly, suppose we are moving from position S1 to S2. Okay. And there is a change of velocity. Either we will go straight with a constant speed, either we will accelerate our vehicle. When we will accelerate our vehicle, so every V2 will be greater than V1, right?
Yeah.
Suppose if we are calculated the velocity over here, so we will find that V1 this and V2 this. So this will be the relation. V2 will be always greater than V1. Okay,
Yeah.
so it is acceleration. We are going accelerated. So if we will say this V2 minus V1, V2 minus V1, and corresponding this, the time is T2, and corresponding this, the time is T1. So it is like T2 minus T1. So it means the rate change of velocity. And this quantity we know gives the acceleration.
Yeah.
Clear?
Yes, sir.
So rate change of, okay, if this case is hold, then it is velocity acceleration. If it happens the opposite, that's we are moving and we applied the brake. Okay, so final velocity will be in deceleration. Deceleration. What will be happen in deceleration? The v final velocity will less than initial velocity, right? In that case also we will define the acceleration in the same way, but we will call it deceleration or retarded. We make a question, right? Then bullet was fired and then it
Yeah.
went sand, right? Sandbag.
Yeah.
Okay. So that was the case of retardation or deceleration. Clear?
Yes, sir.
So if we will take the rate change in velocity, we will be calculating acceleration. And we already know what the unit of acceleration?
Meter per second square.
Meter per second square. Good. So what next we are left with? So if you understand the concept, then this is the problem for you. Can you do it?
Yeah.
Did you understand the question?
Yes, sir.
Okay, all the best.
So I got the answer.
You got the answer? Do I have
Yeah.
to assist you or not?
No, I got it. I got it.
Okay, then. The next is graphical representation of motion. What is the graphical representation of motion? That we will be representing motion in the graphical forms, right? So
Yeah.
on the x-axis, we have time, and along the y-axis, we have distance. Okay. It is similar to linear equation in one variable. We did like there was position x and y. Okay. So we were having the corresponding point in for the x and y. Okay. We got some point corresponding to x and y, and then we plotted, right? So this equation corresponds to uh, like this is x and y, right? So this is a straight line. We already saw some graph over there which was presenting the straight line. Okay. So this was y is equal to mx, right? So m is the slope between these 2 points, right? This may be written as m. Here, if you will write, then on the y-axis, we have distance s and this v and this t. So here v is velocity and which corresponds to m in the equation 1. So that is the mathematical equation, and we will translate that equation in our time velocity graph. So we will get this. Okay. Did you get the point?
Yes, sir.
Do you have to ask any question?
No,
No,
no questions.
no question. So you understand the thing. So this is the equation of motion, and we already, I think we derived this relation somewhere in between. So if you will plot these two equations, you will find a straight line. So if you will calculate the area under the shadow, I'm showing you. Can you find the area of the for this triangle OABC? It is visible.
Yeah.
Okay, so can you find the area of this triangle?
Okay.
Okay, we'll do later. Leave it. We have another problem.
Okay.
We have the problem velocity time graph. This is the no. This is the quite different concept now.
Yeah.
This is quite distance. The area will be length into breadth, but this is not triangle. That's why I'm avoiding it. Sorry, this is triangle. So triangle is half L into B. So the constant will be here. So my point is that if you will calculate the area under position time graph, that is no. That's not true. If you will calculate the slope, this point is that if you will calculate the slope, position versus time, then you will get velocity, right? So that's why this velocity comes over here as a constant, as a slope. So this is slope. If you start with some certain velocity, you will be along this line. If your velocity is higher than this, then it will go like this. Okay. If you start with a slower velocity, then you will go like this. So this is V1, V2, V3. Can you tell me the relationship between V1, V2, V3 in form of less than, greater than? Okay, so how we will say V1 is box less than or greater than V2, then box less than greater than V3. Can you fill it with less than and greater than or equal to?
Um, V1 is greater than V2.
Okay. Whatever it is beyond the standard of your class. So now see the right graph, right hand graph, this one. So see, if I'll draw a tangent along this line, if I'll draw the tangent along this line, if I'll draw the tangent along this line. So you see the slope, you are
Yeah,
seeing the slope now. So
yeah.
what can you say that velocity till this point is greater or smaller than the velocity till this point?
It's smaller.
Hmm?
It's smaller.
V1 and this is, are you having cold?
No, my throat is a bit dry. Like it's not feeling well.
Okay, that's why I shouldn't ask much question to you, na? It will put you in
No,
trouble.
no, it's fine, sir.
So see this graph, the right hand graph, or tell me which when its velocity is smaller, this portion this, we have the portion this. Let me see the another pen, another color pen, red. This portion, I'm grilling you for the no reason, okay? You will may feel in future if you will continue with science. So what is the velocity if we compare in this region, or this region? In which region you feel that velocity is higher?
Velocity 3, the top one.
Velocity 3 is the highest, right?
Yeah,
So here the velocity 3 in the left hand side graph. Now you compare yourself with that graph and let me know. Okay, and another way I'm asking for the left graph, whose slope is larger? V1 slope, V2 slope, V3 slope. Whose slope is larger?
um,
Whose slope is larger?
the
One is like this, one is like this. Oh my God. Okay, one is like this, and another is like this. And I don't have the third pin or any. Okay. And another is like this. We have three slopes, right?
yeah,
Whose slope is larger? This one?
yeah, this one's larger.
So the larger slope corresponds to the V3, right?
Yeah,
So that's V3 is will be larger. So V1 is smaller than V2 and V3. So if I'll write, so I'll say that V3 is greater than V2 is greater than V1, right? This is
yeah,
the order, right? By the way,
yeah.
clear?
Yes, sir.
Now we have another, that was the position time graph. So slope of position time gives velocity. Now we have velocity time graph. So calculate the area of this rectangle. Calculate the area of rectangle. BCD. Calculate the area of this rectangle.
Um, it'll be L into B, so AC into CD.
AC into CD. Okay, that's true. But you have to calculate from origin. Calculate the length from the origin for the time axis and for the velocity axis, and then write it. Suppose this is O. Instead of 0, call it O. Right?
Okay. So I don't understand how to calculate the distance between the origin. I don't understand.
Recall the coordinate geometry concepts. For the coordinate, how we calculate the distance between 2 points?
To calculate the distance, we
The distance between these two points will be simply OD,
the Pythagoras theorem we use
OD
that.
minus OC. If we want to calculate the CD, we will be calculating OD minus OC, we will get CD. Clear?
No, so no, OB, OB minus OC.
OD is not OB. Sometimes my pen behave in some different way to put you in danger. Okay, you didn't call my pen for the party now.
No,
This is OD minus OC. So this distance is OD from here to here, and if we will subtract this part, we will be getting CD, right?
yeah.
Similarly calculate the velocity axis distance.
So it will be it'll be OB minus OA.
This will be OB minus OA.
Okay.
OB
Is equal to
minus
AB.
OA. You don't think that OB minus
OA is
OA
equal
equal
to
to OC OA? You wanna say
no,
OC
is equal to AB.
equal to AB. Just AB, just AB and CD is same. These are the parallel line along the time axis or x-axis, right? So we
Yeah.
already got that CD is equal to AB, CD is equal to AB. We don't have to find. We have, this is the length. If this is length, if this is length, then this is the breadth or height or whatever it is. So you have to
Okay.
calculate this distance, right?
Yeah.
So try.
So what's the distance between the
The
CD? I mean,
CD,
not CD. For OC.
OC. Why we are calculating OC? OC, the distance between OC is OC only. We
Yes, so
we
how
are
do you,
calculating with respect to origin. Okay, each
yes,
distance is being calculated from origin. So this is the OC. This is OD. If we want to calculate CD, what we will do? We will, from this length, we subtract this length, right?
yeah,
If we will subtract this length, we will get this length, right?
yes, so the
That's
number,
what I did over here.
so it will be like,
Leave the number, leave the number for time being, leave the number. If we will calculate in for the number, because I think, uh, see this point, if this is if this was coinciding with this, then it was easy to calculate. 4 minus 1, it is 3, but it's not coinciding with 1, so I'm not taking the number. Okay, I'm also only taking the symbols OC and OD, right? My question was
yeah,
only how what will be the length of velocity axis or y axis? How will you calculate the length of y axis?
the length will be 40 kilometer per hour.
Okay, leave the number, just say me in the symbol A, O, O, B, O, C, like that.
It'll be
This will be
if AC
OC,
AC into CD will be the area of the rectangle.
AC. That's it. So area of rectangle will be what? Area of
Rectangle will be AC into
um,
CD.
rectangle will be AC into CD. That is OD minus OC. Yeah, simply AC into CD. Okay. So
Okay.
why I have written in some complex form? Because along the x-axis we have velocity, right? And sorry, along the y-axis we have velocity. Along the x-axis we have T2 minus T1. So this is area under the velocity time graph gives this displacement, right? So
Yeah.
we got the this is T2. So we got S is equal to VT, very famous relation. Clear?
Yes, sir.
So area under velocity time graph gives displacement. And now I'm leaving you with this. I think we calculated area for this graph as well, right? Somewhere
Yeah, we have, I think so.
we have, right?
Hmm.
So if you remember, I think you will do in a minute. You won't take more than a minute, right?
No, I don't think so. No,
Hmm?
no, I don't. I won't.
So show me the what will be the area of this shaded part.
The area will be area A, B, C, D, and E. So area of rectangle A, B, C, D, uh, plus area of the triangle ADE.
Right.
So uh, the area of rectangle is AB into BC, plus half L into base. So
Okay. That's
half
very good.
AB into DE.
You will do. I know. I know you will do. I think we solved all these. Okay. So
Yeah.
final we also solve. We establish all these three relation. Okay.
Okay.
So I think this was the chapter, and we solved some problem based on these. Right? Do you remember?
Yeah.
Somewhere in between, we solved all these. And I think with this, we completed this chapter. And we solved this numerical as well, I remember. When
Yeah,
we were solving the, what can I say?
force
Uh,
and law
it,
of motion.
uh, in gravitations. So we rewritten these equations, remember, in
Yeah,
form of gravitational acceleration. There we solved all these equations, right?
yeah,
And then your mama messaged me, so I think you taught her the previous chapter. I said, yes, yes, I remember.
yeah.
So I think this is done. We are done with this chapter as two. You try the numericals, I think. Okay.
And the uniform circular motion. So
Uniform circular motion or circular motion? That's the
it
same. Okay.
okay.
When
So
an object moves on a circle, when an object, this was the straight line motion, and the
yeah.
planetary motion is the circular motion. So if an object moves on a circular orbit, then it is called circular motion. Like that. It's the easy concept. If you will read, you will understand.
Okay.
This is the circle of radius r, and an object started from this position and it started traveling on this path. So the circumference is 2 pi r. If we will divide it with t, we will get the velocity. Okay.
Okay.
This will be also the average velocity.
Okay, sir.
If you want to calculate the acceleration, so velocity by time will be acceleration A will be velocity over time. So
Okay,
we
sir.
will get acceleration the same.
Yeah.
So now you read yourself. If you have any confusion, we may connect if you wish. Okay.
Actually, sir, the not physics but maths and that polynomials, I was having doubt.
You may ask questions anytime.
Yeah,
Polynomial. Yeah, we were a little bit in hurry, na.
yeah.
So
The division I was practicing it, but I'm always sometimes getting it wrong. It's confusing for the to get the quotient answer. I'm getting confused.
no problem. You try. The door is open.
Could
Okay.
you do one question now, sir, if you can?
Huh?
Could you do one question now, if you can?
Which question?
And related to factor division.
Vector division. What is the question?
No, just any question to show an example.
Mm, Vector division. You didn't understand the division.
The division, I'm getting confused of how to find the quotient.
Is there another question? So give me a second. These were okay.
Yeah, these all questions were easy.
Okay, only this is nightmare, right?
Yeah, it's a bit hard.
That's why I think such question won't be tackled in your classroom.
No, we did this in our class, but it was confusing for me.
Oh, your teacher solved this question by
Yeah,
division method.
she took it very easily, like saying it's very easy. But I always come to her asking it's very difficult. How do you do it? And she explains, but I'm still confused.
So it was from polynomial, right?
Yeah, this was the main reason I wanted to clear. This is the main thing I wanted to clear in this chapter.
Okay, okay. So um, I will take another question. Right. Sure, sure. Okay, we'll take the same question and we'll explain it to you in the possible way.
Mm.
I'm removing the other part. This part, I think.
So yeah,
This part. This is called the remainder theorem. Okay.
yeah,
So what the remainder theorem says, we started with example. We divided a number 7 by 2. We get 3 to the 6 remainder 1, right?
yeah,
So here is remainder 1. So we may write 7 is equal to 2 into 3 plus 1. Clear?
yeah,
Now take another number like 6 and we divide it by 2. We get 3 to the 6 and remainder is 0. So this time 6 will be written as 2 into 3, right?
yeah.
So if it is a factor, we are getting remainder 0. Clear?
Okay.
Okay. If we are getting remainder 0, it means that this polynomial 6 will be written in term of 2.
2.
Okay. So what we did, this was the question, examine whether x plus 2 is factor of this or not. So
Okay.
to examine this, what could we do? Either we put that f x plus 2 is 0. So we will put it as 0 and then from here x become minus 2. So now if we will replace x with minus 2 in the given equation, then it will be minus 2 cube plus 3 minus 2 the square plus 5 minus 2. How much we did? How much we got?
We got here 2, 4, 8 minus 8 minus 8 plus minus 8 plus 3 into 4 uh, minus 8 plus 12 plus minus
So
5 5
this is
into
minus 18.
5 into minus 7, sir.
5 into minus 2.
Oh, it looked like a 7. Okay.
No, no,
Okay.
no. Okay, so this
Minus.
is 12 plus 6. So we got 0. Clear?
So I can use this method or I can do the division method.
Sorry.
So there's two methods. I can either do this method or the division method.
See, question is not yet completed. The concept is yet not completed. So it says that here we say, see now, if this is the factor, then we will get remainder 0. So if remainder is 0, then this 2 will be the 0 of equation or the polynomial, right? Here what we tried
Yeah.
to see that I divided this polynomial with this and we find that it is 0. Okay. So in this way, we establish this relation. Okay, the remainder is 0. If remainder is 0, so the factor will be written in this form. Then f of this, f of x plus 2 is equal to 0 will also give you 0.
So here, why are we using f a function we're using as minus 2?
That's x plus 2 is 0. So we will put it as a 0. Clear?
Okay, yeah.
Says it is 0. So x will become minus 2.
Okay.
Instead x plus 2, instead x plus 2, if you will do with this, then also you will get the same answer, right?
Yeah.
You divide it and you will get remainder 0. You do this division with this number, right? Write
Yeah.
it like x cube and divided by 2x plus 4. Right. How you will do? First, we have to bring the cube. So will be multiplied by x square, but we don't want, wow, we want 1. So we will divide it by 2. So what it will be? X cube 2 divided by 2. So it will only give you x cube. From here, x square by 4 divided by 2, you will get 2x. Again, subtract this 2. This will get cancelled. We will get x square 5x plus 6. Again, we have to get how much? Positive x
Yep.
square. So we will multiply x by 2. So it will be x into x square by 2 plus here will be 4 into x by 2, it will be 2x. Again, we will subtract it. And I am leaving over here for your practice. It is 3x plus 6. You abhi aur bhi karna hai, we have to do it more. So I'm leaving for your practice, and you will find that you will get remainder 0. Clear?
Yes, sir. Okay.
Take the screenshot to practice and now see this statement.
Okay.
If Px is a polynomial of degree greater than n, n is greater or equal to 1, and a is a real number, then x minus a is a factor of Px if Pa is equal to 0. Clear?
Yes,
It only
sir.
becomes the factor if Pa is equal to 0. We check that. And another word, if Pa is equal to 0, if x minus a is factor of Px.
Okay,
Clear?
sir.
I've
Yes.
shown you by doing the long division method. Clear?
Okay, sir. Yeah.
Any doubt?
No, sir.
Okay, enjoy your exams.
Enjoy my exams, sir.
Of course. Who
Okay.
doesn't enjoy the exams?
Sir, I don't enjoy the exams.
Everyone enjoys the exam.
Sir, my whole class doesn't hates exams.
So you have to change your mindset. Enjoy the exams. If you will hate exams, you will be in trouble in future.
Okay. Okay,
Okay.
sir.
Okay,
Okay.
then